All right, have your textbooks out and open to page 302. You did the review 1 through 4 and 20 at the bottom of the page, reviewing over some inequalities, some compound inequalities. Also had a nice, large, tough-looking equation to solve there. And then we'll go over the radical equations in just a moment at the top of the page, 2 through 14 even. But starting with the 1 through 4 at the bottom of the page, with a compound inequality, we said the key, of course, is to get x by itself, but there's actually 3 different parts to the inequality. But other than that, we solve it pretty much like an equation. The first thing I would need to do here, Josh?
Positive 6 on all sides.
Positive 6 everywhere, right? There's not 2 sides, there's 3 things, but all 3 places put a positive 6. That gives me...
3 is less or equal to 2x is less than 13.
There we go. And then to finish it out, Dylan. And when we do, we end up with what answer?
3 2 is less than or equal to x is less than 13 2.
There we go. All right, and if I were to graph this, remember, 3 halves is really 1.5, right? So if here's 1, here's 2, we'd have a solid dot, remember, right here at the 1.5. This here really means 6.5, so 3, 4, 5, 6, 7. So 6.5, remember, we'd have an open circle, and we just shade everything in between. How many had this answer for number 1? All right, questions on number 1? All right, number 2, 2 steps to solving for the x here. Adam, I know you didn't do it, that's okay, you had homework past, didn't have to do it. But what do we do first on number 2?
You take the 7 and you negativize it.
Negativize it. Good. And so we put a negative 7 everywhere, and we get?
You get negative 5, positive 5.
In those, the 5 and the negative 5 are going to be surrounding a
3x.
3x. So negative 5 is less than 3x is less than 5. Then
you divide it to get negative 5/3 is less than 3. I mean, it'll mean x, and is less than 5/3.
Good. The x ends up being everything between positive and negative 5/3, or 1 and 2/3. All right. So if here's your 0, 1 and 2/3 would be right about here. We'd have open circle. There's positive 1 and 2/3. We should have everything in between those. How many had that for number 2?
What are the ones that we had that you had to make either 2 equations or the...
Those would be absolute value inequalities, and we didn't have those here. We will be reviewing that before the exam, though. We have a negative 2 is less than or equal to a 2x plus 6 halves is less than or equal to 7. Now, there's actually a couple ways you could approach this one, Lana. How did you approach it?
I think I multiply everything by 2.
Good. That's one way. That's the normal way we would approach a problem like this class. We multiply everything by a 2. Now, in this instance, do you see you could actually divide the 2x plus 6 by a 2 and just get x plus 3? Most of the time, you couldn't do that. But in this case, you actually could have. And that would have been the shortcut, is to say x plus 3, which is the division, right, the divided quotient, in between the negative 2 and the positive 7. They just put a negative 3 everywhere. But normally, when we see a problem involving the fraction, we end up having to multiply by the LCD to get, Lana.
Negative 4 less than or equal to 2x plus 6 less than or equal to 14.
Good. And then, of course, we would have to...
Negative 6.
Negative 6 everywhere to get...
Negative 10 less than or equal to 2x less than or equal to 8.
And then finally...
Divide by 2. And then negative 5 less than or equal to x less than or equal to 4.
And by the way, that's the same thing we did if we put a negative 3 everywhere, right? Negative 5 is less than or equal to x is less than or equal to 4. Same answer either way, of course, for the graph. We've got both less than or equal to, so we put a solid dot at the positive 4, we put a solid dot at the negative 5, and of course we shade everything in between. How many had that for number 3, regardless of which way you approached it?
Oh wait, I did do it. Okay.
For some reason, I put up negative 6 at the end.
All right, questions? All right, let's take a look at number 4. This time, as you look at number 4, you realize you can't just divide that 4 away, can you? So on this problem, we needed to multiply everything by 4, add a 4 to all spots, divide everything by 3. What answer do we come up with, Josh, on number 4?
4 is less than x is less than 8.
Really close.
4 is less than x is less than or equal to.
Yeah, less than or equal to
Oh.
8, because there's a less than or equal to there at the end. Otherwise, good to go there. Does anyone need to see number 4 worked out?
No.
All right, any questions on that? Again, that'd be open circle on the 4, solid dot on the 8, and shade everything in between. Questions on compound inequalities? Been a little while, but as we look ahead toward the exam, doing a little bit of review even now. All right, let's drop down to the bottom of the page then, and we had a fairly good-sized equation here, such as,
I didn't really get an answer.
didn't get an answer.
It was something,
I did.
it was like something equals.
We should have had not just an answer, but we should have ended up with 2 answers on this one. Let's take a look here, Dylan. First of all, when solving equations, I want to get rid of parentheses. And in this case, I've got a couple sets of parentheses, but to get rid of them, I'm going to have to foil. First, outer, inner, last. What do I get right here when I foil, Dylan?
2x squared negative 5x negative 5.
Oh, I see. Negative 12, when you foil, you went ahead and combined the negative 12 with the positive 7 and went straight to the negative 5. Okay, that is correct. All right. On the other side, what do we get when we foil? Adam?
3x squared, negative 1, oh wait, at the very end. Oh wait, that's the end.
So you're doing first and last. Okay, what about the outer inner?
2x plus 2x.
Well, negative 3x,
Oh, negative.
positive 1x ends up giving me a negative 2x in the middle. Of course, we still have this negative 2. If we wanted to do what Dylan did, just combine the negative 1, negative 2 to get
Negative 3.
negative 3. All right, questions on the foil, the combining, all of that stuff. All right, now at this point, I see x squared. And if they matched, they would cancel and I'd be very happy. But they don't cancel, which means, class, we're stuck with a quadratic. And what is the key to solving a quadratic equation, class? Set it equal to 0. So Lana, if I want to set this equal to 0, which side should become the 0, the left or the right? I mean, technically either, but there is a best answer here. The left side, because I want the x squared to be positive. And that means getting rid of the little one. The little one's the 2x squared. Let's get rid of it by moving it over as a...
Negative 2x squared.
to get
1x squared.
1x squared. At the same time, then, let's move the negative 5x over as a...
Positive
and that gives us...
3x.
And let's also move the negative 5 over as a...
Positive 5 to get 2.
There we go. And now that it's been set equal to 0, Josh, I need to...
Make 2 equations. Oh wait,
eventually...
no. Do the 2 parentheses.
Set it equal to 0 and, class...
Is it
factor, backwards foil,
Yeah.
right? So we need a backwards foil here. Josh, what do we get?
X and x, and then positive, 1 and 2.
And check that outer inner.
Yes.
It does work out. Now we're going to make 2 little equations. They'll usually I do these in my head. 0 equals x plus 1, x plus 2 equals 0. In both cases, to get the x's by themselves, I'm going to have to move the 1 over and the 2 over. I am getting what 2 answers back to Dylan?
X equals negative 2, negative 1.
Good. Negative 1 and negative 2 are my 2 answers. Or either way, it doesn't really matter, right? Negative 1, negative 2, negative 2, negative 1. Either way, those are the 2 answers for x. How many got those on number 20?
X squared plus 3x negative 2.
And at that point, you wouldn't be able to
I think
factor
I
it.
forgot the negative 1. Like combining the negative 1 and negative 2 at like that.
Okay. Questions on this? Questions on this? All right, that's all old review. Now let's get to stuff we've been talking about more recently. In fact, in our last lesson, introduced you to a new type of equation, equations with radicals. What do we call these equations with radicals in them, class?
Radical equation.
Radical equations, very good. Now, technically, where there's a variable in the radical, but whatever. And with the radical equation, I said there's 2 key steps. If you refer your notes if you need to, for reference, those watching on YouTube, they have had a 3-day weekend, so they may have forgotten since then. So refer to the notes if you need to. What's the first key step? to solving a radical equation. Class?
Isolate the radical.
What is it, class?
Isolate the radical.
Isolate the radical. And once we've isolated the radical, step number 2 is to
Square both sides.
square both sides. Now, if it's a cube root, you'd cube both sides, 4 through, you'd raise both sides to the 4th power. In Algebra 2, or Algebra 1 rather, we're primarily focused on square roots. So for our purposes, it really is going to be isolate the radical, square both sides. What are the two steps, class?
Isolate the radical, square both sides.
Adam, what are those 2 steps?
Isolate the radical, square both sides.
All right, so on number 2, as we look at the homework now, you did 2 through 14 and even. They've already isolated the radical. So all I got to do, class, is square both sides. And when I square both sides, on one side, I am squaring a square root. And class, when you square a square root,
You get the radicand.
you get the radicand. So I square the square root of y, class, I just get
Y.
y. The square and the square root cancel. On the other side, I'm squaring a 3.
9.
9. I'm done. Now, there is a possibility, I said, with radical equations that you could do all the steps perfectly and get an answer that doesn't check. What do we call an answer that you didn't make a mistake, it just doesn't check, class?
Extraneous roots.
Extraneous roots. And I told you, extraneous roots often come about if you end up doing what?
Square a negative.
If you
Yeah.
square a negative, because that sign change where a negative becomes a positive and all of that, here I didn't square any negatives. It's very unlikely I have an extraneous root, but if you wanted to check square root of 9, yes, equals 3. And we're good to go. On the next one, we have the square root of r equals 8. Well, when I square both sides, what do I get, Adam?
R equals 64.
And is the square root of 64 equal to 8?
Yes.
Yeah, it checks out. How many got r equals 64 for number 4? Number 6, we have the square root of 3x plus 5 is equal to 8. Here, takes a couple of steps here. First of all, we have to isolate the radical because they didn't do that for us this time, Lana.
-5.
On both sides to get?
Square root of 3x is 3.
All right, and now that we've isolated the radical, now we will
Square root of both sides.
square both sides. When we square both sides, what do I get?
Square root of 9x.
No. When
No,
I
it's
square a
3x.
square root, I get the
I had
radicand.
3x.
Good. Don't second guess. All right, and then on the other side, I get
9.
9. And then here, we have to do one more step to finish the process out, Lana, because we're not done solving yet.
Divide by 3.
Divide by 3 to get x equals 3.
I got 1.
Okay, and then what we're going to do is we're going to plug it back in. Now, Lana, if we have the 1, let's check the 1. What is 3 times 1, Lana?
3.
What's the square root of 3? I don't know. But if you add that, your rational value to a 5, you don't get 8. So that's how you could have checked your answer. Let's check our answer now, the 3 that we got this time. What's 3 times 3, Lana?
9.
Square root of 9
3.
plus 5, does that equal 8? Yes, so there
I
it
had
checks
3. I
out.
don't know what it is.
All right, number 8, we have the square root of y negative 2 is equal to a negative 17. Joshua, what do we need to do?
Square both sides.
Yeah, they already isolated the radical. We'll square both sides. And on the left side, when we square the square root of y minus 2, we get?
Y minus 2.
Because, class, when we square a square root,
You get the radicand.
get the radicand. On the left, right-hand side, what do we get, Josh?
289.
289. And then we got to finish it out, Joshua, by...
Adding 2 to both sides.
And when we do, we're going to get y is equal to
291.
291. That's a big answer. Let's plug it in. 291 minus 2, class.
289.
Square root of 289?
17.
17. Not negative 17. It implies a positive square root. So therefore, this answer doesn't check. Notice we squared a negative. That's usually a sign that that's going to happen. What do we write for our answer then, Josh?
No solution.
No solution. And again, class, what kind of answer is 291?
Extraneous.
It's an extraneous root. It's a root that we got by solving. We didn't make any mistakes. Like 5 would be a wrong answer. That's not even extraneous. That's just wrong. 291 is extraneous. We did all the right steps. It just didn't check out. No solution. Our answer on number 8. How many have that? Look at the next one. We have the square root of x negative 5, all equal to 6. Dylan, walk us through.
Square both sides.
Okay, because they already isolated the radical.
X minus 5 equals 32.
Okay.
Plus 5 on both sides. X equals 31.
All right, or you can say move the negative 5 over as a positive 5 would work as well. We check the 41 minus 5.
Yes. No.
What's 41 minus 5?
37. 6.
36. And what's the square root of 36?
6.
6. And so it checks out. There's our answer.
It's Monday.
It's Monday, yeah. No, Tuesday, rather. It feels like a Monday.
It's in
we had
quotations,
field day
Monday.
So it wasn't really a
Everything
complete
flew
day
off.
at all.
Yeah, it's a weird feel coming back off field day. Okay. Adam, on the next one, what do we need to do?
You need to subtract the 7.
Good, or move it over as a negative to get,
You move it to become 8.
or it becomes an 8, there we go. And then,
Then you square them both.
to get,
Then you have like you move the
what do I get?
Well, you have the radical answer,
Which is?
z negative 5
Equals,
64.
alright, and then?
And you put the 5 into a positive, so then you have 69.
There we go. Let's check real quick. What is 69 minus 5?
64.
Square root of 64
8.
plus 7?
15.
15. And that checks out. How many had 69 for number 12?
Right.
Okay, questions?
I have 230.
Oh boy. Alright, question.
I don't think so. I don't know why.
I think, Lana, you squared both sides before you isolated the radical. Because that would have put you into the 200s somewhere.
Yeah.
Isolate the radical, then square both sides. Now, number 14 is a fun one, and this was the last one you had for homework. We're going to look at a couple more like this today, where here you've got a radical equation, but not only do you have a variable inside the radical, you've got a variable outside the radical as well. What this is going to do is it's going to make the equation go a little funny on us, but we don't change our process. We still, class, isolate the radical, already done for us.
Square both
Square both sides. So that's where we're going to start, is with the square both sides. Now, of course, on this side, you're squaring the square root of x plus 12, class, because when you square a square root,
You get the radical.
but on the other side, it's a binomial that I'm squaring, and when I square a binomial,
Square the
Square
first,
first,
square
square
the
last,
last,
multiply
multiply
and
and
double.
double.
Yeah.
and so when I square the first, I get,
X
X
squared.
and I square the last, 36, but I don't forget to multiply and double, 12x.
Yeah.
And so, all of a sudden, what started out as a radical equation, class, has become a quadratic equation. How do we solve quadratics?
Set it equal to 0.
Set it equal to 0, like we did earlier on the other homework problem. So, which side should become the 0?
The one with the x squared.
The side without the x squared. We want the x squared to be positive.
Oh,
I put the 0 here,
Yeah,
that
I
would
know
move
what
this
I
as a negative. I don't want that. Put the 0 here, leave the x squared as the positive, bring this x over as a,
Negative.
to get,
11.
bring the 12 over as a, to get,
24.
and then after we set it equal to 0, factor. Class, we set it equal to 0 and factor. In this case, it's backwards FOIL, not always, but in this case, it is backwards FOIL. Frankly, most of the time it is. That's why we call this a quadratic trinomial. Of course, the x squared is going to be x and x. What about my signs?
8 and 3.
Signs, positive, and then the numbers, 8 and 3. So the outer gives you the 11. When we set both of these equal to zeros, move the 3 and 8 to the other side. So we end up with two answers.
Negative 8, negative 3.
But we got to check. And I told you, we only looked at a couple of these at the end of the hour last time. But I said, when you've got a couple answers, it's very possible that one of them is extraneous. Not a guarantee, but very possible. Let's take the negative 3, because that seems easier. Negative 3 plus 12.
9.
Square root of 9.
30.
Negative 3 plus 6. 3. That checks out. We like the negative 3. Now we're going to plug in the negative 8. Negative 8 plus 12. 4. Square root of 4.
2.
Negative 8 plus 6.
Negative 2.
Negative 2. No, this one's extraneous. Now we don't write no solution, because we do have a solution. Negative 3 is a solution, right? Negative 8 is extraneous, but since we had another answer to fall back on, we're going to say that is our solution. And something a little weird that can happen there when we've got a radical equation that involves a non-radical variable as well. Did anyone get those two
Not
answers?
quite.
Okay, front row, good. Questions, back row. All right, did you guys on the front row catch that the negative 8 was extraneous?
Yes.
Good, excellent. So you did both steps through. Excellent. Good. Questions from the rest of us? We'll practice a little bit more with this here in just a moment. Before we do, I want to go back and review something we've been working on last week, and that was rationalizing denominators. What does it mean to rationalize a denominator, class?
Take the square root.
Take the root of the denominator. And most of the time it's a square root, but not always. Take the root of the denominator. Or in other words, get roots out, right? Now, in some cases, we have a problem here, for instance, as you write this down in your notes, the fourth root of 5 over 8x squared y cubed. We've done things like this for a while now. Maybe not with the letters in the denominator so much, but we've done problems like this, where it's all one big fraction. We got to find a way to take the root of the denominator. I always start by looking at the number first, and I would ask myself, can I take the fourth root of 8?
Or no.
No.
It's cube.
But I could take the fourth root of
16.
a 16, or an 81, or a 625. You figure your fourths, right? 2 to the 4th, 3 to the 4th, 4 to the 4th, rather, that's 256, 5 to the 4th, that's 625. Like, you could figure these. Fortunately, we get it on the first try. 2 to the 4th, 16, that's my target, right? So we're going to change this from an 8 into a 16. But I also have to look at the letters. And remember with the letters, class, to take the root of a power, you divide the exponent by the index. Class, what do I do to take the root of a power?
Divide the exponent by the index.
I have to divide 2 by 4. In other words, 4 has to go into a 2. Huh? 4 can't go into 2. What can 4 go into?
4.
4. So in other words, if this were an x to the 4th, I could say 4 goes into 4. Can 4 go into 3?
No.
No. So maybe I'd be like, well, let's get a y to the 4th. Because 4 can go into 4, right? And so we said if we extend the radical sign a little bit, I could multiply top and bottom by,
X squared y.
well, you're right about an x squared and a y, but also the 2. 2x squared y would give me the 16x to the 4th, y to the 4th. And what we do to the bottom?
You do the top.
So we're going to multiply the top by a 2x squared y as well. My numerator ends up becoming what here, Lana?
10x squared y.
10x squared y.
Is
And I
this
can't
in our
do...
book?
What?
This one isn't in our book.
No, I told you in your notes, write this down. Yes. Make sure you're listening. I know you're tired though, we're all tired. So in the top, can I do anything with the fourth root of a 10x squared y, class?
No.
No, but I don't care because it's a,
Numerator.
and I don't care about numerators. I only care about denominators. And I can take the fourth root of 16x to the 4th y to the 4th, class.
2x.
2x
Y.
y.
That's it.
2xy. So I didn't hear the y earlier.
The
Now, can I then say, oh, 10 divided by 2 is 5, and y is, can I do that?
No.
No, because this is radical, this is not. We'll leave our answer just like this. Write this down if you would. A over the cube root of 3x to the 7th. A over the cube root of 3x to the 7th. Now here, instead of seeing all one big fraction, only the denominator has a radical. The steps really don't change. We just have to be careful with a little technicality here in just a moment. But I still approach it the same way. In the denominator, I have to be able to take the cube root of the number first. Well, can I take the cube root of the 3?
No.
No, but I can take the cube root of
27.
27.
No.
I could take the cube root of 8, but a 3
Yeah.
can't become an 8. So we'll go with a 27 instead. Can 3 go into 7?
No.
Well, I mean, it can, but not evenly, and it has to go evenly. So since 3 doesn't go into 7 evenly, what's another number 3 could go into evenly?
21.
A 9. Now, it could go into a 21, Lana. You're right. That's awfully big. I want the smallest possible number. 3 can go into 3, too small. 6, still too small. 9, that's something I can shoot for. So we want to go for the smallest possible exponent that I can change this to. So here's the question. Be careful on your answer. How do I change a cube root of 3x to the 7th into a cube root of 27x to the 9th? Good. Multiply by the cube root of 9x squared. Not by 9x squared, but by the cube root of 9x squared. And what we do to the bottom, so we're going to multiply the top by the cube root of 9x squared also. So what does my numerator become, Joshua?
9 times times the cube root of 9x squared.
There we go. Where here, this was all under the radical, so it all kind of mushes together. Here, this is not under a radical, so it doesn't mush with this, they both parts still exist. Now, the top I can't do anything with, and I don't care. But in the denominator, I can take the cube root of 27x to the 9th class. 3x cubed. And there's our answer. Questions on this? Remember working on this last week?
Yeah.
All right. Now then from there, we said, well, that's great as long as it's just like single terms. But what if we had a two-term radical denominator? We said, well, then you're not just trying to get a single root. There's two different roots going on. It's a big mess. What did I say we would have to do if our denominator had two terms and at least one of them was a radical, class?
Multiply by the conjugate.
Multiply by the conjugate. What do we do, class?
Multiply by the conjugate.
Now, what do we mean by conjugate, Adam?
The thing reversed with a different sign. How describe it?
Maybe Dylan can help you describe it better.
Multiply by the same thing, but the sign is different.
Okay, you gave a little bit more detail than Adam did.
Just
All right.
multiply by
The conjugate in this case would be what, Adam?
3 minus 5 times the square root of 2.
Good. The same denominator. You multiply by the exact same denominator, but you swap out the middle sign so that we create what in the bottom, class?
A sum and difference.
A sum and difference. And when we have a sum and difference, class, what do? 3 things.
Square the first, square the last, minus sign between them.
And what we do to the bottom.
Gotta do the top.
Now, in the bottom, I multiply by the conjugate. But another way to say this is, in this problem, I multiply by 3 minus 5 squared root of 2. So in the top, what do I multiply by, class?
3 minus 5 squared root of 2.
Right, you don't multiply by the conjugate at the top or anything weird like that. What you multiply by the bottom, you gotta multiply by the top. So in the bottom, yes, I'm gonna square the first,
9.
square the last. There's 2 parts.
25 times 2.
25 times 2. Because when you square a square root,
You get the radical.
but this isn't a square root, it's a 5, so that's why we get the 25. Here we just get the 2, and then we put a minus sign between it. In the numerator, though, I don't square the first, square the last, put a minus sign. What am I doing in the numerator? Back to Adam.
You're foiling.
I'm foiling. So when I multiply the first, I get
18.
18. When I multiply the outer, I get
Negative 30 times the square root of 4. No, 2 times.
negative 30 times the square root of 2. Then when I multiply the inner, Lana, what do I get?
Negative 3 times the square root of 2.
And then when I multiply the last together, Lana.
Negative 5 times the square root of 4. Positive 5 times the square root.
But what is the square root of 4, Lana?
2.
2. So it's really 5 times 2, or in other words, that's just a 10. Then I can do a little bit of combining here at the top, and 18 combines with the 10, Josh.
28.
And the negative 30 square root of 2, and the negative 3 square root of 2 gives me.
Negative 33 square root of 2.
And then in the denominator, Dylan, I've got this 25 times 2, of course that becomes a 50. So really this says 9 minus 50.
Negative 41.
Negative 41, but I don't want to leave the answer like this, class.
Bring the negative up to the front.
Slide the negative out to the front. So we'll remove it from the bottom. We'll put it in front of the fraction bar, and there's our answer there. Remember working on this. All right, questions on the rationalizing denominator? 'Cause it's been a little while since we looked at that. Wanted to make sure, kind of refresh your memory on that. Questions?
Nope.
All right, let's go back to radical equations then. And write this down in your notes. 3 times the square root of x minus 4 minus 2 equals 13. And at your seats, take just a moment to solve. He's just having a fun time. All right, check your answer.
Yep.
Did you bring the 2 over as positive, get 15?
Mm-hmm.
Did you divide by 3 to get 5?
Yep.
Square both sides to get x minus 4 equals 25?
Mm-hmm.
Add 4 to get 29?
Yes.
At any point, did a square a negative?
No.
Then if I'm a gambling man, I don't waste my time checking. If I'm not a gambling man and I've got the time on a quiz or test, I plug the 29 in, but it will check out for us.
You're just
Look back at page 302. Look back at page 302 now. Copy down number 20. Got the square root of 6y plus 7, all equal to a y plus 2. Number 20. Copy down.
I got confused. I thought it was
Again, no change in the steps because it's a radical equation. Step number 1, class?
isolate.
Isolate the radical. But that's already done. So step number 2 is where we're going to start.
Square root.
What do I get when I square both sides, Josh?
6y plus 7 equals y squared positive 4y plus 4.
Outstanding questions.
No.
All right, now what, Lana?
you factor?
Not yet. I've got this quadratic now. What do I do with quadratics?
Oh, 0.
Set it equal to 0. We are going to factor, we got to set it equal to 0 first. So let's put the 0 here. Lana, when I shift stuff over, what do I end up with?
Negatives. Well, you put negative 6y from there. So it would be y squared negative 2y negative 3.
Good, and also put a negative 7 to get negative 3. Now that we've set it equal 0, Lana, now we will factor, and we get?
Y plus, and then y negative 3.
Good, y and y signs are different, 1 and 3, and if you work the signs out like Lana did, we end up getting that negative 2y outer inner. So 2 possible answers for y, class.
Negative
Negative
1
1
and 3.
Negative 1 and positive 3. Now, usually one of them comes out extraneous. Let's check them both. I want to start with the positive because that seems easier to me. Let's start with the 3. 6 times 3, class,
18.
plus 7,
25.
25. What's the square root of 25?
5.
5. All right, what is 3 plus 2?
5.
And sure enough, the 3 checks out. So at this point, I'm expecting the negative 1 probably not to work, but let's plug it in anyway. All right, 6 times negative 1?
Negative 6.
Plus 7?
13.
Oh, negative 6 plus 7?
Oh,
1.
1. Square root of 1?
1.
Negative 1 plus 2?
1.
Oh, they both check out. That can happen sometimes. So don't fall into the trap of assuming, oh, this one checks, the other one doesn't. It's possible they could both check. It's just very frequent that one of them doesn't. Number 21, copy that one down if you would. Got a 4 plus a 2x minus a square root of x minus 4, all equal to a 3x.
Well, all that.
This time we're going to have to do the whole process because our normal first step class,
Isolate the
Isolate the radical.
oscillate the radical. I don't know where that accent came up. Isolate the radical. So everyone is isolate the radical. And now it is a negative radical, so I could shift it over to make it positive and then bring the 3x over. Do double switch. Or I could just move both the 2x and the 4 over. Dylan, what do you want to do?
Double switch.
Double switch it. All right, let's do it. So we're going to leave the 4. We're going to bring the 3x over as a negative, which is going to give us,
Negative.
and then we're going to ditch the negative square root of x minus 4 as a,
Positive.
good. Notice it's just the sign in front that goes from a negative to a positive. The radicand does not change. It just goes from being a negative square root of x negative 4 to a positive square root of x negative 4 with an understood positive. Now that the radical's been isolated, class, square both sides. And on the left-hand side, when we square both sides, what do we end up with, Adam?
The 16 x positive x squared plus 8 negative 8x.
Negative 8x. There we go. Square the first square less, put multiply and double. Yeah. And we get 6 times 0.x. You were focused. It's all good. 16 negative 8x positive x squared. On the other side, what do we get, Lana? It's not the fun one, sorry.
Just x negative 4.
Now, one thing of note here, notice the ascending order. Let's flip it all around. So now let's put the x squared first. I would put the negative 8x, but let's bring this over and make it really class negative 9x. And let's also bring the 4 over as a positive to get
20.
positive 20, all equal to 0. Do you see what we did there? We kind of rearranged as we set it equal to 0. I think we're capable of doing that in our heads. And then at this point, class, backwards FOIL, again. And of course, x and x, negative, negative, 5 and 4, good. So 2 answers for x.
5 and 4.
5 and 4. Let's go back to the original equation here and let's check. Let's start with 4, seems easier?
Yes.
Right? So 4 minus 4, class.
0.
0. What's the square root of 0?
0.
0. 2 times 4.
8.
So we have a 4 plus 8
12.
minus 0.
12.
12. And then 3 times 4.
12.
12.
Okay.
All right. Let's check the 5 now. 5 minus 4.
1.
Square root of 1.
1.
2 times 5.
10.
So it's 4 plus 10
14.
minus 1.
13.
13. And then 3 times 5.
15.
Oh. Yeah, that particular answer, class, is extraneous. But we still got one of the answers to check. Questions on radical equations? All right, clear desk except for a clean sheet of paper and a pencil. Clean sheet of paper and a pencil. Everything else away.
I literally called it.
Don't waste your own quiz time. Clean sheet of paper and a pencil, everything else away. I'm going to write the homework on the chalkboard for those watching on video, so pause it once the homework's up there, focus on the quiz, and after the quiz, copy down. Obviously, students here will be able to copy down after their quiz also. All right, sheet of paper, pencil, everything else away. First and last name at the top of your paper, along with today's date. First and last name at the top of your paper, along with today's date, which is 5/10?
5/10 is.
22? 5/10/22?
This is quick.
And this is quiz 35. Quiz 35.
Is this the last quiz?
You'll find out. All right, let's take a look at the quiz very quickly together. Numbers 1 through 5, write the word or phrase that would complete each of those statements. For 6 through 9, rationalize the denominators. And numbers 10 through 13, solve those radical equations and check. Roots that do check, circle as your answers. Just cross them out if they do not check. All right, you may begin. Like I say, the homework will be on the chalkboard.